Hello students and welcome to the next lecture on alkaloids, which is quinine part 2nd. Today we will discuss on constitution of meroquinine, oxidation of meroquinine, structure of cincholoiponic and loiponic acid, point of linkage of quininic acid and meroquinine, position of alcoholic group, and finally the structure of quinine. First of all, the molecular formula. With the help of elemental analysis and molecular weight determination, the molecular formula comes out to be 6,9H15NO2. Second is the presence of vinyl group, which was already present in basic structure of quinine. It absorbs a molecule of hydrogen and forms a dibromo derivative with bromine, which means that the conclusion is the vinyl group is present in quinine was intact in meroquinine. Next is the oxygen atom. The functional nature of oxygen atoms. There are two oxygen atoms in meroquinine, and the functional nature was found to be as follows. It forms a monosodium salt, which means that a carboxylic group is present in meroquinine. Next atom which is present in the molecular formula is the nitrogen. What is the nature of this nitrogen? It is revealed with this following experiment. It forms a nitroso derivative and monobenzoyl derivative. These two reactions are characteristic of the nitrogen in the form of secondary amino group. So the conclusion drawn is that the nitrogen is present in the form of secondary amino group. Next we come to the oxidation, which gives useful information about the structure of meroquinine. Meroquinine on oxidation with acidic KMnO4, cold acidic KMnO4, it forms formic acid and cincholoiponic acid, which on further oxidation it gives another dicarboxylic acid, which is loiponic acid, with the formula C7H11NO4. The formula of cincholoiponic acid is C8H13NO4. As you can see, the difference in the molecular formula of cincholoiponic acid and loiponic acid is 1 carbon atom less in loiponic acid and 2 hydrogen atoms less in loiponic acid. That means CH2 methylene group, there is a difference of CH2 group in loiponic acid and cincholoiponic acid, methylene group. The conclusion drawn from this oxidation or degradation method is, first, the formation of formic acid. Formation of formic acid indicates the presence of vinyl group of quinine. This means that the vinyl group is retained in meroquinine. Second conclusion drawn from this oxidation degradation method is cincholoiponic acid is the higher homologue of loiponic acid. This means that cincholoiponic acid contains 1 CH2 more. Next, loiponic acid easily isomerizes to more stable hexahydrocinchomeronic acid on treatment with KOH. It isomerizes to hexahydrocinchomeronic acid. So the structure of loiponic acid should be piperidine 3,4 dicarboxylic acid. 1, 2, 3, 4 dicarboxylic acid. So the structure of loiponic acid is piperidine 3,4 dicarboxylic acid. This important conclusion is derived with the help of KOH. Next we come to the structure of cincholoiponic acid. As you know that silco-loipoic acid contains 1 CH2 more than the loiponic acid, and we know that the structure of loiponic acid, in this earlier slide we have drawn the conclusion that it is piperidine 3,4 dicarboxylic acid. So the structure of loiponic acid, there are two probable structures, structure 1 and structure 2. There is CH2 group, methylene CH2 group here we have inserted here, and in the second structure we have inserted in this one. Now what is the structure of these, either 1 or 2? So evidences in structure of favor of structure 1. First is, on heating with concentrated sulfuric acid, it forms gamma picoline. Gamma picoline is 1, 2, 3, 4 methyl pyridine. Gamma picoline is 4 methyl pyridine. So the formation of this gamma picoline reveals that the CH2 group is present in here. So the structure of structure 1 is favored according to this reaction. Next evidence in favor of structure 1 is the synthesis. So the synthesis of loiponic acid, first the important compounds which we have taken is the beta chloropropione acetyl. Beta chloropropione acetyl, 2 molecules of beta chloropropione acetyl and ammonia. It undergoes this reaction and forms imino-dipropione acetyl with the formula here. The two beta chloropropione acetyl molecules have joined, and with the help of NH3, and in the presence of HCl, this acetyl group is removed and it converts into CHO dial group, which is unstable, which again it undergoes dehydration and forms this unsaturated compound with the double bond and a CHO group. This CHO group, on reaction with this is hydroxylamine and second is thionyl chloride, this CHO group converts into nitrile group CN. This compound undergoes Michael condensation with malonic acid in the presence of sodium ethoxide and converts here. This condensation takes place. This CHCOO C2H5 twice group is inserted at position 4th. Next, on hydrolysis with barium hydroxide and then treatment with HCl, this ester group converts into carboxylic acid group and it undergoes decarboxylation, converting it into CH2COOH group, and the cyano group here at position 3rd is also hydrolyzed into COOH, resulting in the formation of cinco-loiponic acid, which is a racemic mixture. Since cinco-loiponic acid is obtained along with formic acid by the oxidation of meroquinone, it must have a CH double bond CH2 group. So the probable structures are structure 3rd and structure 4th, where we have inserted here CH double bond CH2 and here it is CH double bond CH2. So evidences in favor of structure 4. So the probable structure 4th is the probable structure. The evidences is meroquinone on heating with HCl at 240 degrees centigrade, it forms 3-ethyl, here 3-ethyl 4-methyl pyridine, which is only possible with this structure, with the structure 4th, where vinyl group is present, CH double bond CH2 group, it converts into ethyl group, and here it converts into the methyl group. Next is the meroquinone on next evidence in favor of structure 4th is meroquinone on reduction with zinc HI gives cinco-loipone C9H17 and O2. Here you can see Syncholoipone is found to have a carboxyl group and an ethyl group. This is carboxyl group and this is ethyl group, which ethyl, the formation of this ethyl group reveals that the vinyl group is present at position 3rd. If it is present at position 4th, then a propyl group would be introduced at this position. So these two are the evidences in the favor of structure 4th. Thus the degraded products are as follows. Here you can see this is the probable structure 4th of meroquinone with a vinyl group at position 3rd and CH2COOH group at position 4th. On oxidation it forms syncholoiponic acid. This is degraded into COOH here, and then again it again converts into loiponic acid. Here CH2COH is again removed. So these are the series of oxidation reactions which we have understood. Next point, a very important point, is we have determined the structure of meroquinone, and in the previous lecture we have determined the structure of quininic acid. Now in quinine, how are they joined? Means the point of linkage between quininic acid and meroquinone. This is very important from examination point of view also, since quinine has no carboxylic group but its oxidation products, that is quininic acid and meroquinone, have carboxylic group. The two moieties are linked with each other by carbox. This means these two carboxylic group has diminished in quinine, which means that a point of linkage is through these carboxylic carbon atoms. Second is the quinine is a di-tertiary base, while meroquinone has a secondary nitrogen atom. Very important, in quinine we have just determined that it is a di-tertiary base. In my previous lecture I have already discussed this. While in meroquinone it contains a secondary nitrogen gear. This means that during oxidative degradation, a tertiary nitrogen has converted into a secondary nitrogen atom. During oxidation of quinine, the second moiety is oxidized in such a way as it converts tertiary nitrogen into secondary one with the introduction of one carboxylic group. One carboxylic group is also introduced in meroquinone. So the precursor of meroquinone has the following structure. This is vinyl quin nucleodine structure. This is vinyl quin nucleodine structure. And as you can see, this is the structure of vinyl quin nucleodine, which is the precursor of meroquinone. On chromic acid oxidation, here the cleavage takes place. This nitrogen converts, here you can see it converts into secondary amino group, and this CH2 group, it oxidizes into COOH group. So CH2COH group. So this is the precursor of meroquinone, which is equivalent to, as you can see, meroquinone. Very important precursor of meroquinone. So the quinoline moiety is joined at position 4th to the quin nucleodine moiety at position 8th. This is quin nucleodine moiety is at position 8. This position is attached. So the point of linkage is quinoline position 4th and the quin nucleodine at position 8. Now how these are joined? Is there direct connection between the two moieties, or they are joined through any group? This is a very important position of alcoholic group, as we have already studied that quinine, it contains a secondary alcoholic group also. So this position of alcoholic group was given by Rabe, scientist Rabe. He oxidized quinine to quinone, this quinine to quininone by chromic oxide, which on treatment with amyl nitrite and HCl, this is amyl nitrite and HCl, gives nitrous acid. So if the structure of, or the middle structure is C double bond OCH, on treatment with nitrous acid, amyl nitrite and HCl gives nitrous acid, it converts it to quininic acid. This is quininic acid. And the second is an oxime. This is oxime formation takes place, and these two products reveals the presence of COCH group here, which isomerizes to oxime. C double bond O, their rearrangement takes place and it converts into oxime. So the inference drawn from this series of reaction is that quinoline and quinnucleidine units are linked through a secondary alcoholic group, as you can see, CHOH. As you have already seen the COCH, this CHOH, this is the point of linkage between the two moieties. So the structure, final structure of quinine is here. You can see the meroquinine structure. The joining is through position 8th of this meroquinine. This is the secondary alcoholic group, and the position 4th. 1, 2, 3, 4th. Fourth position is the secondary alcoholic group. So point of linkage is position 4th and position 8th of meroquinine and position 4th of the quinoline nucleus. At 6th position there is methoxy group. We have already structure. So this is the final structure of quinine. This is all about the quinine, and the important points is the structure of meroquinine, the position of secondary alcoholic group, the point of linkage between quininic acid and meroquinine, and the degraded products of this quinine, cincholoiponic acid, loiponic acid. All these are important from the examination point of view. So the final structure, as you can see, there is a quinoline moiety with a methoxy group at 6th position, secondary alcoholic group, and the meroquinine structure. Thank you.